All right, well, we're going to continue on with our naming system of acids, only this time we're going to need to take the name and turn that into the formula. So for example, suppose we had acetic acid, ACETIC, acetic acid. And we remember that acetic acid, we're going to go ahead and make our scales because we think it's going to be an ionic. It's acids are related, so we're going to use that same sort of system for it. On the left-hand side would be the hydrogen, as we know. We don't know how many. We're going to have to figure that out. And on the right-hand side would be what? Well, we have to remember that acetic, the ic came from 8. So at some point in time, this ion on the left was the acetate ion. So then we go looking on our sheet for the acetate ion, and we discover it at the top of our polyatomic. It's C2, H3O2. And that is the acetate ion, and it's a -1 in charge. So it looks like those are balanced right there. So it's time to write our formula. So that would be 1H with C2H3O2. And again, I'm suggesting the use of parentheses early on in your career to let you know that this is all one polyatomic ion, and the hydrogen is the cation over on the other side. So that's the formula. But again, if you look in the book, it would simplify that to be HC2H3O2. And they don't combine this hydrogen with this hydrogen. So it doesn't do that. It keeps the hydrogen alone on the left to indicate it's acid. We'll try another example there. So carbonic acid. Once again, this came from a scale, so we're going to go ahead and do a scale. But we realized that when we did that, there were hydrogens on the left. We don't know how many. We'll figure that out in a moment. And on the right, there was some sort of anion that we need to analyze. This again is an ic, so that means it must have came from an ATE ending. So this was indeed the carbonate ion at one point in time. If you look on your sheet on the right, the carbonate ion has a formula of CO3 and a charge of -2. So in order to get this to balance, we must have needed another hydrogen here. And now it looks balanced to me, so I'm ready to write the formula. H2 parentheses CO3 end of parentheses, just one of those. And if I clean that up, we're going to make that H2CO3 as the name of carbonic acid. And if you remember that from a previous video, you might remember that that is the one that's in soda pops, carbonic acid. If you watch the other video on acids, you're probably aware that there's another whole type of group of acids that have the name of hydro in front of them, like hydrofluoric acid. This is the acid that can etch glass. So again, we start off with our scale. We know that there were hydrogens on the left and only hydrogens on the left. But we don't know how many of them. And on the right side, this ic means at one time that was hydrofluorine, INE. And then that got changed to IDE. So this was FLUORIDE at some point in time. And that got changed, the ending to ic, when we made the acids. So fluoride, we remember, is the F-1 anion. We can notice that they're balanced out, and so it's time to write the formula. HF is the formula for hydrofluoric acid. It's as simple as that. So if you're having trouble, I'd suggest you go back and watch the other video on naming acids, the one that changes from the formula into the name. And remember that if it has the name of ic, that means it came from ate. Something you ate made you ick. And if it has the OUS ending, that means it came from an anion that had an ending of ITE. And so that'll help you. These again are only for when the anion had an oxygen in it. Otherwise, you had a prefix of hydro, and the ending was ick, and that was when the anion had no oxygen. That's as simple as it is.